Hi, Advanced Algebra and Trig. We're going to get into solving absolute value equations and absolute value inequalities today. So one of the first things we want to do is to define what absolute value equations are. So let's go ahead and jump right into that. One of the first things we notice about an absolute value equation, if absolute value of x is equal to c, then x can be both a positive and a negative c. So x can either equal c, and it can also equal negative c. Let's see how that plays out in an equation like this. When we're solving for the absolute value of an equation, there are two rules that I like to follow. The first rule is that you need to get the value or the absolute value by itself. The second rule of the process is we need to split that then into two equations. Right now, in this problem right here, we already have the absolute value isolated. It's already by itself. So we can go into step 2, or goal 2, or rule 2. And that is that we can write two different equations. Either 2x minus 5 equals 3, or 2x minus 5 is equal to negative 3. Now, because you have a positive and negative, there's a possibility that this might yield an answer that actually doesn't work. So when we solve these, we'll make sure to plug them back in. Here we have adding 5 to both sides. 2x is equal to 8, x is equal to 4. And over here, adding 5 to both sides gives us 2x is equal to positive 2. And so x is equal to 1. To double check to make sure that this doesn't create a negative on the other side, we're going to plug it back in and say 2 times 1 minus 5 is the absolute value of that equal to 3. And we get negative 3 and 2 times 4 minus 5, absolute value of that is equal to 3. And this gives us 8 minus 3, which is a positive 3. And yeah, both of these check out. So that means that both of these are totally answers for that problem. Now let's try one that rule 1 needs to be applied to get the absolute value by itself. If that's the case, we're not going to split it until we get the absolute value by itself. So I'm going to do operations like minus 5 on both sides and get 3 times negative x minus 7 is equal to 9. Divide by 3 on both sides. You don't need to show that work, but you still have the result is equal to 3. And lastly, I get to rule 2, which is split this up into two answers. X minus 7 equals 3, and x minus 7 equals negative 3. From there, simple solve, add 7 to both sides, x is equal to 10, and here x is equal to positive 4. Those are my two answers, and so we just leave them as is. Now we can take this over to inequalities. No problem. I want you guys to see the inequality chart that we have here. And notice that if an absolute value, when you solve it for the absolute value, is less than a value or less than or equal to a value, we're dealing with a graph that looks like this. And if the absolute value is greater than a value, we're looking for something that looks like this. We know that every time we step into an inequality. So we don't need to have any guesswork of whether it's going in or going out. We just need to know, is it greater than, equal to, or less than and equal to the value? Let's take a look at the first one and realize that that is going to fall along the lines of less than. So I know my answer is going to be coming just like the top values. It's going to have two values on the outside, and it's going to go between the two. Let's find out what those values are by separating them right here. Now, I don't need to do much because I can actually set these equal to an equation because I'm really only looking for the boundary values. I know that it's going to go on the inside, so I can just set this equal to 2 and negative 2. So here I have plus 5 on both sides. I get x is equal to 7. And over here, plus 5 on both sides gives us x is equal to 3. I don't need to even bother with the inequalities because I know my answer is going to be inside of those two. All right, I could use the inequalities, but my answer is going to be 3, 7, not included, so we're not closing that. And I'd write it like this. X is between 3 and 7. Or I could write it as 3, 7 in interval notation, or bracket notation, really. The other one over here, we know that it's greater than, so it's going to be the lower of the two. Since this this absolute value is greater than a value, I know that my answer is going to be going out. So I'm going to have something right here going out and something right here going out right there. They're going to be filled in because this is an equal sign, so I know what this is going to look like. I can just split it up into two things and find the boundary values. So I have 3x plus 2 is equal to 4, and I have 3x plus 2 is equal to negative 4. I work this through. I get 3x is equal to 2, and x is equal to 2/3. And over here, I get 3x is equal to negative 6, and x is equal to negative 2. And I can put this together on a number line and say, all right, negative 2 right here, 2/3 right here, and they're filled in values because they include those two values right there, and it's opening out for both. The way that I would write it, again, is I'd write it as two things. X is less than or equal to negative 2, and, or x is greater than or equal to 2/3. The other way that I'd write it with the bracket notation is I'd have to write it as two different things from negative infinity up to negative 2, included here, excluded there, and this right here, bracket of 2/3 up to infinity, like that. A little bit crammed in there, but that's how we would work it. All right. We could solve these with the inequality intact. It ends up looking the same, so it's just nice to ignore that because you know, based on this chart up here, what it's going to look like at the very end. All right, so let's take it into the real world. The specifications for a car engine indicate that the pistons have a diameter of 3.8745 inches with a tolerance of 0.0015 inches. This means the diameters can vary from the indicated specifications by as much as that value and still be acceptable. So the question goes here, find an inequality involving an absolute value that describes that possible range. And so what we realize here is that if D is the diameter that we have right there, minus 3.8745, if I take the absolute value of that, it has to be less than or equal to 0.0015. Okay? What we're doing right here on this side over on the left is saying, okay, the difference between what we know should be the value And what any particular piston is in its diameter has to be less than or equal to the tolerance over on the other side, which is 0.0015. So what we can do is we can find that high and low value. Now, this one's actually pretty easy. You didn't need to really write an inequality to do this, because you could just basically add and subtract the 0.0015 to this number right here. But this helps us to set up harder problems that might come up in the future when we're not dealing with just a basic plus and minus, and we might deal with some other operation that's going on. We have this inequality dealing with a tolerance to say our high and our low value. Now, right here, because it's an inequality and it's less than, I know my answer is going to look like two dots right here, and it's going in, it's between those two. So I can just find those bounds. So 2d minus 3.8745 is equal to 0.0015. And we also have d minus 3.8745 is equal to negative 0.0015. So when we add this to both sides, we get d is equal to, I'm going to make sure I get this right and use a calculator here, even though I don't think I need to. That would be 3.8760. I can double check that right there, with a value of 3.8745 plus 0.0015. Yep, we get that same value right there. And then we could do the same thing over on the other side, and d is equal to that minus the other one, second value. Bring this over with a minus, and we get that other one, which is 3.873. So we realize that those are the values, the high and the low, for this tolerance, or really for the acceptable values. And so we could write that as 3.876, comma, 3, oops, let's put it in the right order, 7.3 and 3.876. Those are our high and low, both included. We could also put that on a graph, 3.873, 3.876. And we could write it as a inequality like this also, if we wanted to, too. All right. I hope you enjoyed our time together, and make it a great day.